This is the lesson for 2-8, no, one, and infinite solutions. Every equation that you've solved up to this point has had one solution. You've always had a letter equals a number, whatever that number happens to be. It might be positive, it might be negative, it might be a decimal, but up till this point, you've always had x equals a number. That has been one solution. Well, today you're going to have some weird kinds of equations. You need to determine if it has no solutions at all. There's no answer to the problem. If it has one solution, so x equals a number, or if it has infinite solutions. You must completely solve the equation. One solution, like I said, is every type of problem that you've had to this point has had one solution. You've gotten answers like x equals 3. 3 was the only answer to the problem. Or you got like x equals -1. -1 was the only answer to the problem. Well, today, you're going to have some that are no solution or infinite solutions as well. In a no solution question, there is no answer to the question. It's an unsolvable equation. All the variables are going to cancel out. So all the letters are going to disappear. And you're going to be left with different numbers on each side of the equal sign. You're going to end up with answers like this. 2 equals 3. Well, does 2 equal 3? No, that doesn't make any sense. Those are not equal to each other. I put a little slash there to say not equal to. Doesn't make any sense. You might get like 4 equals -1. That doesn't make any sense. 4 and -1 are not the same number. Then you're going to get infinite solutions. With infinite solutions, all the variables are going to cancel out. So again, your letters will cancel out sometimes. And you'll get the same numbers on both sides of the equal sign. So you're going to get answers that look like this. 2 equals 2. Or, depending on how you solve it, you might get like 3x equals 3x. You'll get the same thing on both sides of the equal sign. You might even get something like this. 2x plus 1 equals 2x plus 1. As soon as you have the same thing on both sides of the equal sign, you know that is infinite solutions. So one solution is just x equals a number. No solutions is all the letters are going to disappear and you're going to have different numbers on both sides because it doesn't make any sense. No solution doesn't make any sense. Different numbers. Infinite is the same thing on both sides. And we'll talk about what that means in a second. So let's take a look at this one. In this one, you have variables on both sides. So the first thing that I would do, I like working with the smaller of the two letters first, is I would do -3x and -3x. Bring down your 7, bring down your equal sign. 5x minus 3x is 2x. Bring down our -11. This is just a two-step equation now, plus 11 plus 11. So I have 18 equals 2x. Divide by 2, divide by 2. And you get 9 equals x. X equals 9, or 9 equals x. 9 is the only answer. So this one, when you're figuring out if it's no, one, or infinite solutions, this would be one solution because 9 is our only answer. In this next one, when you have these big, long, complicated equations, remember you always have to follow this order. Look for the distributive property first. Then look for combining like terms, then look for variables on both sides. So do I have the distributive property in this question? Do I have parentheses? No, I don't. Do I have combining like terms? Do I have letters or just plain numbers on the same side of the equal sign that I can add together? Yes, I do. I have a 9x and a -3x. 9x plus -3x is 6x. Bring everything else down that you didn't use yet. So bring down our 10 plus 6x, bring down our equal sign, bring down our 15. Now, we need a symbol in between there. This was a +6 when we added those together, so I'm going to put a +6. So I did combining like terms. Next thing I'm going to look for is variables on both sides. Do I have letters on both sides of the equal sign? Yes, I do. So I need to get all the letters onto one side. I need to do -6x and -6x. Those cancel out. These cancel out. All that I'm left with now is 10 equals 15. All of my letters canceled out. They disappeared. All that I'm left with is two numbers, and they're different numbers on each side of the equal sign. Well, 10 does not equal 15. That doesn't make any sense. So that is no solution. There is no answer to this equation. No numbers could you sub back in and do a check and have it work. So there is no answer. It's an unsolvable equation. So when all the letters cancel out like they did this, and you end up with different things on both sides, it is no solution. Take a look at the next one. Do I have the distributive property? No, I don't. I don't have parentheses anywhere. Do I have combining like terms? Yes, I do. I have a 7x and a negative 12x on the same side of the equal sign, which gives me negative 5x. I also have a 2 and a 1, just plain numbers that I can add together to be a plus 3. Bring everything else down yet that we didn't use yet. So we didn't use this negative 5x at the beginning, or the plus 3, or the equal sign. So I did my combining like terms. Now, technically, you could stop right there because I can see clearly that I have the same thing on both sides of the equal sign. As soon as you get the same thing on both sides of the equal sign, that is your indication that you have infinite solutions as soon as you end up with the same thing. But what happens if I took it one step farther? Right? If I took this problem one step farther, the next thing would be variables on both sides. I would do plus 5x and plus 5x. Those would cancel out. These would cancel out. All I would be left with is 3 equals 3. When all the letters cancel out and you end up with the same thing on both sides, that is infinite solutions. Well, what does infinite solutions really mean? Well, that means every single number is an answer to this problem. Any number that you would pick to do a check and sub in to here would check because essentially both sides of the equal sign are the same exact thing. And we showed that after we combined our like terms. We had negative 5x plus 3 and negative 5x plus 3. For example, if I took a 0 and subbed it in, I would have negative 5 times 0, which is 0, plus 3 is 3. Subbing in a 0 here, I'd have 7 times 0, 12 times 0. Those two red circles would disappear. All I would have left is a 2 plus a 1. 2 plus 1 is 3. Notice that I got 3 on both sides, so 0 was an answer. If I took a 1 and subbed it in, well, I'd have negative 5 times 1, which is negative 5, plus 3 is negative 2 for that side of the equal sign. If I sub in a 1 here, I'd have 7 plus 2 minus 12 plus 1. 7 plus 2 is 9. 9 minus 12 is negative 3. Negative 3 plus 1 gives me my negative 2. Notice that I had the same thing on both sides of the equal sign. So 1 would be an answer. If I took a 2 and subbed it in, that would check too. So every single number you could possibly think of is an answer to this equation. Go ahead and pause the video. Try this one on your own, please. In this one, we would have to do the distributive property first. We have 2 instances of it. 3 times x is 3x. 3 times 2 is 6. 5 times x is 5x. 5 times negative 4 is negative 20. So I did the distributive property. Do I have combining like terms? Do I have letters on the same side of the equal sign? No, I do not. So I can't do that. Do I have variables on both sides? Yes, I do. Minus 3x minus 3x. So I have 6 equals 2x minus 20. Now I just have a 2-step equation. So I'm going to do plus 20 and plus 20. So I have 26 equals 2x. Divide by 2, divide by 2. We get x equals 13. 13 is my answer. That is the only answer that would check if I went to sub it back in. If I went to sub it back in, I'd have 13 plus 2, which is 15. 3 times 15 is 45. And on this side, 13 minus 4 is 9. 5 times 9 gives me 45. That is the only answer that would check. So that is one solution. That is the only answer. Go ahead and pause the video. Try this one on your own, please. This one has another instance of 2 distributive properties. 6 times 2x is 12x. 6 times negative 2 is negative 12. When we write it, we're going to put minus 12. Then we have 4 times 3x, which is 12x. 4 times negative 5, which is negative 20. So I did my distributive property. Do I have combining like terms? Do I have letters on the same side of the equal sign? No. Do I have plain numbers on the same side of the equal sign? No. So I'm going to look for variables on both sides. I have a 12x and a 12x, so I'm going to do minus 12x and minus 12x. Those all cancel out. Notice what happens. All my letters cancel out. My letters totally disappeared. And what I'm left with is two different numbers on different sides of the equal sign. It doesn't make any sense that negative 12 equals 20. So there is no solution. It's no solution because all my letters canceled out and I got different numbers on the two sides of the equal sign. Go ahead and try this last one, please. Pause the video. So again, I want to look for a distributive property first. I definitely have distributive property here. I'm going to bring down my 8x. 4 times 4x is 16x. 4 times 3 is 12. 4 times 6x is 24x. 4 times 4 is 16. I'm going to bring down my minus 4. So I did the distributive property. Do I have combining like terms? Do I have letters on the same side of the equal sign? Yes, I do. 8x plus 16x is 24x. I also have plain numbers on this side of the equal sign that I can add together to be a positive 12. Bring down everything that I didn't use yet. And now I did combining like terms. Technically, you could stop right here. Notice that I have 24x plus 12 on this side, and I have 24x plus 12 on that side. Immediately when you have the same exact thing on both sides of the equal sign, it is infinite solutions. But if you took it one step farther, right, for variables on both sides, you would take and do minus 24x and minus 24x. Those would disappear and those would disappear. All my letters disappeared. Notice that I'm left with the same thing on both sides, which is infinite solutions. So again, when you go to solve these equations, you have to follow that order still. You have to do distributive property first, then combining like terms, then variables on both sides. Once you get down and solve it, if you get x equals a number, that's one solution. Doesn't matter what number it is. If all the letters cancel out and you get the same number on both sides, that is infinite solutions. If you get all the letters cancel out and you get different numbers on both sides, that is no solution.